Hello everyone, welcome to the video lecture series of data structure. Today we are going to learn about the doubly linked list concept and the insertion in doubly linked list. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, first we talk about the doubly linked list concept and how we can implement the doubly linked list, how we can create the doubly linked list, what are the pointers that exist in the doubly linked list, and then we'll see the insertion operation in doubly linked list. So here first the doubly linked list concept. See, the node of the linked list contains, I usually say that the node of the linked list contains two things. One is data, one is pointer. Again students, one is data, one is pointer. Here when we talk about the data, so we call the data as info and the pointer as link. But in the doubly linked list students, we have the two different things. Like one is data itself, and then in addition of the data, we have two another pointers. One is left pointer, one is right pointer. So if here is your data, then this is your left pointer, this is your right pointer, then the whole node, it is known as doubly linked list node. So in doubly linked list, our node contains two things. One is data and another two are the pointers. So total three things are there: data, left pointer, right pointer. Fine. So here it is. Usually we call the left pointer as LPTR and right pointer as RPTR. Now, this whole combination of the data and the pointers is known as node. So, this is my doubly linked list. Students, in single linked list or in circular linked list, as we know, the first is a pointer which is pointing to the first node of the list. First is a pointer which is pointing to the first node of the list. Same like that, students. Here we have two different pointers. Not I'm talking about the LPTR and RPTR. Okay, I'm talking about the left and the right pointer. So, students, here you can see the in doubly linked list. In doubly linked list, the two pointers are there. That is known as L and R. So L is known as the left pointer, which is pointing to the leftmost node of the doubly linked list, and R is the right pointer, which is pointing to the rightmost node of the doubly linked list. So you can also say like that, sir, L is pointing to the first node of the doubly linked list and R is pointing to the last node of the doubly linked list. So yes, you are right, correct. L leftmost, that means we can say like a first, and rightmost we can say like as a last node. See, the first node, that means the first node of the doubly linked list, the left pointer of the first node is pointing to null and the right pointer of the last node is pointing to null. So what we call it is a left pointer or right pointer. So students, we have one unique name, that is LPTR and RPTR. I already told you about it. So here when we talk about the left pointer of the first node, okay, so let me know which pointer is pointing to the first node. Which pointer is pointing to the first node? L. Okay, so we can also say, students, that LPTR of L is equal to null in doubly linked list. LPTR of L is equal to null. LPTR, that means it shows the left pointer of L is equal to null and the right pointer of R is equal to null. So students, the next, let's understand some terminology like what we call, I already told you, but just understand with the animations. Like first, this is my doubly linked list. Okay, 10, 40, 23, 53, 75, all values are there. Now, this thing is known as the node. The combination of data and two pointers is known as node. Next, 10 is pointed by the L. L is the left pointer which is pointed to the leftmost node of my doubly linked list. Here is my R, which is known as a right pointer, or I can say the R is pointing to the rightmost node of my doubly linked list. Fine. Now, what about this? See, this is LPTR of L, which is pointing to null. This is RPTR of L, which is pointing to the next node. Here, LPTR of R is pointing to the previous node. LPTR of R is pointing to the previous node of 75 and RPTR of R is pointing to the right side, that means null of 75. Fine. So students, here I can usually say that my LPTR of L is equal to null and RPTR of R is equal to null. When we talk about the next node, if you want to move further in this doubly linked list, then we can directly go like rptr of L, and previous we can go with LPTR. Fine. So here it is, the all node combinations LPTR of L, RPTR of R is equal to null. Now what happens if my doubly linked list empty? Students, you know that when my singly linked list is empty, then the first is a pointer which is pointing to the null. So same like that, if my doubly linked list empty, then L and R both pointing to null. So students, what happens when the first pointer is pointing to null? So when the first pointer is pointing to null, we can say that linked list is empty or linked list doesn't exist. Same like that, when my doubly linked list is empty or doubly linked list does not exist, then L and R both pointing to null. Now, the next one is how we can insert a value in doubly linked list. Student, this algorithm is very much specifically for the insertion of doubly linked list. Okay, but during the insertion in the doubly linked list, students, what we have specified over that we are going to insert on the left side of the specific node. So this algorithm is specially designed for the insertion in doubly linked list, where we are going to insert a new node on the left side of a node whose address is M. It is written over there, you can also read it, that we are going to insert a new node on the left side of a node whose address is M. So we do not think much, we just need to insert a node on the left side of a node whose address is M. So let's start with the steps. So here you also need to remember some basic condition, that which type of cases we are going to take during the insertion of this particular algorithm. Okay, so very first, this is a doubly linked list insertion. It is a procedure because we are not going to return anything from here. What we need left R, L and R, both pointers are there. Then X is a value which we are going to insert, and M is a pointer, or we can say the address of a node to which left we are going to insert the new node. Okay, so M is the address of a node. On left side we are going to insert a new node. So very the first, just take out L, R, M, then insertion X, and now the first step to obtain the node from the availability stack. Yes, the steps are same as the previous one, but we are not going to write down all the steps. We just need to write new arrow node. New arrow node. Student, here in algorithm we assume that when we talk about the node, it contains all three things: one data and two pointer. Get it from the availability stack. Okay, so do not need to write about the avail, check about the avail conditions, because we did it in the previous algorithms just for our understanding. But this is the WLS algorithm. We already know that how can we perform the availability stack in the insertion operation over there. How can we take the new node from the availability stack? So we do not need to write those steps again and again in the WLS. We can just directly write that new arrow node. This new arrow node statement itself means you are going to, in the availability stack, take a new node with data and two pointers. Fine. So what will be the next step? See, when we talk about the new arrow node, our new node is created over there. Okay, and the new pointer is pointing to it. This is our new node. Now, next, copy the information. Okay, very first step, just initialize the node by writing info of new is equal to X. So what will our next step after inserting the X over there? The next step is insertion into an empty list. That means one question over there, students, that are you going to insert in an empty list? Okay, so students, let's check that whether my doubly linked list exists or not. Are we going to insert a new node in empty linked list? So how to check? See, when our linked list is empty, doubly linked list is empty, then my L and R both pointers are pointing to null. You can check with anyone. Here I am going to take is if R is equal to null. If you are taking that if F is equal to null, then it's also fine. Because if R is equal to null, then L must be null. Okay, so anyone you can take, either L or R, anyone. Okay, so here if R is equal to null, then there is no linked list over there. There is no node in the linked list. So whatever the node we are going to take, it becomes our first node. It becomes our last node. So what happens? L and R both pointing at that particular node only. Fine. So what to write? L arrow R arrow new. Okay. Yes or no? Because who points to whom? L and R both going to points new. So here is a statement. If R is equal to null, L, that means L is equal to null. No linked list exists. So it's LPTR and RPTR both null, and L and R both points to new. Here it is. Instead of pointing to the null, L and R both points to new. Fine. So this is how we can insert a new node when doubly linked list there is no link node is exist. That means there is no node in the doubly linked list. Then what happens? Whatever the node we take from the doubly stack, it becomes our first node, it becomes our last node. So both my L and R both pointing to that new only, and its left link and right link. That means LPTR of new and RPTR of new becomes null. Now the next one. So then the next situation is we want to insert in a leftmost insertion. That means M is at our L. We want to insert where happens like our new node, whatever you want to insert is at the left when the M is equal to L. So student, situation is like this. You can say, okay, here L and R both are here. Okay, but if M is equal to L, that means my L is also M. So what is our motto of this algorithm? We want to insert a new node on the left side of the M, on the left side of the M. So just imagine a situation when M is equal to L, then what happens? So let's see. If M is equal to L, then don't think much. Just take your new node and put on the left side of the M, and then think which link I should need to connect first. So here is my new node. See, I didn't connect any link over here. Okay, so here is my new node. Okay, it is already ready. I have just initialized its information X only. So now before starting connection any link, okay, you have to remember that in linked list during insertion, if we want to connect any link, then first we need to connect the link of a new node only. Okay, so first always try to connect the link of a new node. Okay, so now the RPTR of a new, see, RPTR of the new is going to connect L. Okay, so here it is, RPTR of new is going to connect L, and LPTR of new becomes null because there is no node on the left side of the new. Fine. So RPTR of new is going to point M or L, whatever you want to write, and LPTR of new becomes null. So here are the two steps. The LPTR of the new becomes null, and the RPTR of new is directly connected to M or L, whatever you want to write, because here L and M both are same. Now what remains? What remains, students? Only the left link of L or M. So just write LPTR, left link of M, left pointer of M. That means LPTR of M is going to point new. So here it is. LPTR of M is going to point new. So now the insertion is done. One thing is remaining. Which is your leftmost node? Which is your leftmost node? L or new? After inserting on the leftmost, obviously new becomes my leftmost node. So just move L from here to new. So L point to new and write written. Okay. So such like this you can insert a new node on the leftmost side of the doubly linked list. Now the next, if it is not like this, then what to do in next case? So here it is my case, students, where I want to insert in middle of the doubly linked list. So students, what I need to do over here, I just need to insert something in the doubly linked list. Fine. This is the step where we want to insert a node in the middle of the something. So the situation is like this. You can see over here, like we have 10, 40, 23, 42, 53, and the last one is 80. Okay. Now the node which I want to insert, it is in the left side of the M. 9 my M is pointing on 42. Fine. So what I need to do is, students, I need to insert new node on the left side of the M in between of 23 and 42. Okay, so the situation is clear. In an exam, or to remember this algorithm, always remember that you need to draw a figure and then think about that what link I want to connect on the which position. Fine. So let's start the algorithm. See, this is my X. This is my X. What I told you that always remember, try to connect the links. Try to connect the links of a new node first. Then think about the rest. So tell me, students, the right link of the X, the RPTR of the X is going to connect what? M. See, the RPTR of the X is going to connect M. Fine. So the name of the 42 is M. But what is the name of the 23? Do we have? Yes or no? Because in linked list, name that means a pointer, okay, nothing else. Name means a pointer which is assigned to that particular node. So who is pointing to that 42? M. That means name of 42 is M. Who is pointing to that 23? Who is? LPTR of M. See, the left pointer is of the M is pointing to 23. Okay, the left pointer of 42 is pointing to 23. Okay, so the very first step that we need to do is that the LPTR of new is pointing to LPTR of M, because this link, the 23 link, is known as LPTR of M. So here it is, my LPTR of new is pointing to LPTR of M. Okay, and the next step is RPTR of new is pointing to M. So here it is, RPTR of M is pointing to M. So RPTR of new is pointing to M, LPTR of new is pointing to LPTR of M. Both links are connected with each other. Now what to do? Now just think, okay, carefully. We need to break link between 23 and 42. Okay, so first I'm going to try the LPTR of M. Okay, so now the LPTR of M, students, see, LPTR of M is breakdown and going to connect with new. So here it is, LPTR of M is gone and connected to new. Now tell me, what is the name of 23 now? Because we have already removed the left link of M. I did it intentionally because you need to aware about this. If you remove the left link first, then there is no name for LPTR of M, because after connecting LPTR of M to new becomes my LPTR of M. There is no existence of 23 over here. But wait a minute. See, the LPTR of LPTR of new is connected to 23. That means the name of 23 is LPTR of new. So what to do? Just write down like this: RPTR of LPTR of new. Students, why RPTR of LPTR of new? Because 23 is the left side. Because students, 23 is on the left side of a new. 23 is on the left side of the new. That means the left pointer of the new is connected to 23. Okay, so now the identity of the 23 is LPTR of new. Okay, we want to connect the right link of 23. We want to connect the right link of 23. So right link of, that means RPTR of 23. 23 is known as LPTR of new. So the whole term becomes RPTR of LPTR of new. Got it? So RPTR of LPTR of new is going to connect new only. So here it is, the RPTR of LPTR of new is going to connect the new itself. Okay, so such like this, we can insert a new node in between of doubly linked list. And last step is return. So students, in this lecture we talk about the doubly linked list, how we can do like LPTR, RPTR. The very first most node of the doubly linked list is pointed by L, and the last node is pointed by R. You already know about that. How can we insert a new node on the left side of a node whose address is M? Okay, fine. So if you have any doubt, then please feel free to ask me. Thank you so much.